Okay, perfect. So, we've pegged out, using our peg and line, present floor. And now that we know that this is the section that we're going to be studying, it's just going to make your life an awful lot easier. So there's a variety of things that we have to measure. The first thing that we need to do is measure the width of the river at present flow. So we need to literally try and measure the water surface from peg 1 to peg 2. What's it important that we try and ensure when measuring the width using something like a tape? Yeah, it's taut, it's tight, so that the water doesn't drag it and cause the tape to bend, because obviously if the tape bends, you are going to mismeasure the width, and that will throw out a variety of different other results that we're going to be looking at. If width is wrong, then cross-sectional area is wrong. If cross-sectional area is wrong, then discharge is wrong and hydraulic radius is wrong. So it's really important that we're as accurate as we possibly can be. Okay, so present flow, I'm not going to walk all the way back over there. We make sure that the tape measures as tight as possible and you take your readings. The data recording sheet will tell you the units of measurement. Okay, can we make sure that we're recording width accurately? Okay, once we've calculated our width, we can then start to take our depth measurements, and we need to take 10 measurements, and then we're going to calculate an average depth. And by knowing the width and the average depth, we can work out the cross section. Okay, so how do we work out our intervals for taking depth measurements? So once we know what the width is, we need to take 10 measurements. Does anyone remember what you divide it by? 11, good. So you take the width, divide it by 11, and you get your interval for taking these depth measurements. Right, why is there not a little ruler in there? Okay, I've just taken these from Alex McNulty's group. Who has the ruler, the big ruler from that group? And also the Satsuma from that group. Okay, so we've calculated our width, we've worked out our depth intervals, and there are a few things that we can do to kind of save time whilst we are working all of these things out. So we go to our first interval, we put our ruler in, and we take our depth measurement. Okay, it's important that you take it correctly. At the moment, I'm not really stood in an appropriate position to be taking a depth measurement. Why might that be? I'm blocking the river's flow because I'm stood upstream. So you need to be stood downstream so you're not disrupting the flow, and you need to try and get as low to the water surface as you can, obviously without getting your backside wet, so that you can take an accurate measurement. Okay? So you're going to take your depth measurements at each of those intervals, but to save time, I think, at the same time, once you've taken your depth measurement, you could do your sediment sample. So you pick up whichever rock it's touching, and you can then do two things. You can measure sediment size, and you can also determine the sediment roundness. So you can kind of kill two birds with one stone, without the pun. So, I didn't mean that. Right. So, to work out its roundness, if you go into your clipboard, there should be, he says, a powers of roundness chart. You decide which of the shapes on there best reflect the stone that you have sampled. I would advise that at any given site, just one person does sediment roundness, because it's based on opinion. If 5 different people do 10 different rocks, it's not really that consistent a survey, so you need to try and make sure that one person does the roundness. When you come to sediment size, and you should have a 30cm ruler in your bag, I happen not to have one in this bag. How do I determine the size of that rock? This rock has what we call an A axis, its long axis, a B axis, kind of its width, and then C, which is the depth of that rock. Which one do we measure, A, B or C? B. Jacob, why B? Can you remember the reason?
Is it because that averages out the A and the C?
Not quite. It's to do with if this rock was in the river and it was being transported, it's most likely to be transported along its B axis as opposed to being transported along its long axis. So we measure B, so we get our ruler, we look for an appropriate place to take our B measurement, and again you try and be as accurate as you possibly can do. If you have a smaller ruler, it will be much easier than using this one. Once you have taken your measurements, be careful where you're putting your rock. So for example, don't chuck it there because you might pick it up when you get to your next sample. Put it somewhere out of the way, and obviously just be careful placing things back into the river. So we've done our width, our average depth, and at the same time we are doing sediment size, and we're also doing sediment roundness. Okay, the next thing that we have to do is wetted perimeter. So that takes into account all of the lumps, the bumps, the undulations that you'd experience along the bed of a river. So this time, you take your chain and you place it along the bed of the river. Before I do that, what's it important to know about your chain before you even start? How long it is. Because this section of river is not that wide, but we will look at wider sections where it may be that you have to use the chain more than once to get all the way across. So if you know its known length, it again just makes your life a lot easier and makes recording a lot quicker. So you place your chain along your peg and line, taking into account all of the lumps and bumps and the undulations. You get it back out and you measure the length that has been wetted by being on the bed of the river. That's going to give us our wetted perimeter. Once we have our wetted perimeter and we've calculated our cross-sectional area, we can then measure the river's hydraulic radius. In other words, how efficient is this section of the river? Okay, so we need to make sure that wetted perimeter is also measured as accurately as possible. Okay, he's getting your hands wet as well, but it's actually not that cold today. Right. The last thing that you have to do is velocity, and we are using the float method. So we put our peg and line in place. That's the section of the river that we're going to be surveying. So using your ranging poles, we need a known distance. So we're going to go for 10 metres. So you need to place a ranging pole 10 metres, 5 metres, sorry, upstream of your peg and 5 metres downstream. So you know that that's your 10 metre stretch. I'm not going to bother going downstream, and I'm not even going to bother measuring it out. You all know how to use a tape. But we're going to go up 5 metres, and let's say 5 metres is about there, okay? Using the stopwatch on your phone, you need to time how long it takes for your Satsuma to travel that 10 metres. But it's important that we do this survey on more than one occasion so we can calculate an average. Why is it important to work out an average velocity as opposed to just one reading? It's more accurate. What could happen if I just did it once and put my Satsuma in? It could go in the foul leg and it could whiz past, giving us a really fast reading. On the other hand, it could get stuck on an obstruction and take an age to travel that 10 metres. So again, would give us an inaccurate and unfair reflection of the river. So we're going to take 3 readings. Where do you think, in terms of the river's width, where are we going to take those 3 readings? Halfway? So a quarter, a half, 3 quarters. So you take your width, you work out halfway, you work out 1 quarter and 3 quarters, and you take your readings in those 3 places. Right, one last thing before we can kind of move on. At the moment, I'm stood in line with my ranging pole, and we're going to time how long it takes for this Satsuma to travel that 10 metre stretch. Can anyone see a potential problem with me standing directly at the ranging pole, ready to drop in my float? Because as soon as it hits the water, or as soon as it gets in line with that ranging pole, we need to press go on our stopwatch. If I put it in the water now, it takes a little while for it to settle in the water and begin moving. So what we're going to ask you to do is to just take a step back from your ranging pole and place your satsuma in, and then someone needs to be stood at that ranging pole, so Oliver for example, and as it passes he's going to shout go, and the stopwatch will go on. There will be someone at the second ranging pole ready to say stop, and there'll be someone beyond that ready to catch the satsuma. Again, if it goes past you, do not dive in after it like Mrs. Farrell did. It's a satsuma, we'll just give you another one. Right.
So my measuring this is 5 feet, isn't there? It's 2 people in the water.